Hello, my name is Daniel, your GRT Mill Lead for the 2020-2021 season. Today, I will be introducing the milling machine, showing what it does and how it works. By the end of this video, you should be familiar with the basics of operating the milling machine. You will have to pass an online test covering this material before receiving hands-on mill training. Before we get started though, remember to make sure you're following the safety rules of the shop. Wear your safety glasses at all times. Always you'll roll up your sleeves. Tie back your hair. Make sure your shoulders, midriff, and back are covered. Closed-toed shoes. Pants or shorts that cover your knees. No dangling objects. And check the people around you. Milling is the process of removing material using a spinning cutter. It is for making accurate parts with tight tolerances. You can reduce the length of box beams and the width or length of flat stock. There are two main operations you should know: facing and drilling. However, there are many more operations. A facing operation cuts across the end of a part, making it square and decreasing it to an accurate dimension. Drilling operations make holes. In the GRT shop, we have two manual milling machines. This one is called Rocky, and this one is called Bullwinkle. In between the two milling machines is a workbench that houses supplies and tools for both. In the top drawer, you'll find small supplies like center drills, edge finders, and more. Below that, there are drill chucks and boring bars. Below that are the parallel bars. Right above the drawers, there is a drill bit chart. This is the same chart as the one found by the drill bits near the vault, and can be used as a quick reference whenever you need to find the actual diameter of a drill bit. This is Rocky, one of our two milling machines. Here I'll go over the parts. First up is the power switch. The switch has labels forward and reverse. We normally use the forward option for facing and drilling. The forward option spins the tool clockwise, while the reverse option spins the tool counterclockwise. The speed change hand wheel adjusts the RPM of the spindle. Only change this when the motor is on. On Bullwinkle, the speed is changed by moving a belt to pulleys of different diameters. We'll be going over changing speeds in more detail in a later video. The speed dial shows what RPM the machine is set to. The spindle is connected to the pulleys and does the actual spinning, as well as holding the Colettes. The spindle brake is used to stop the spindle after turning the machine motor off. It can be activated in either direction. The quill contains the spindle, and it moves the spindle up and down. The quill stop knob moves up and down along with the spindle, and the micrometer nut is used in conjunction with the quill stop knob to stop the quill at a certain depth. The quill lock is used to lock the quill in place. It should be used while doing a facing operation. The quill feed handle is used to raise and lower the quill. The milling machine has a high-range gearbox for high-speed operations and a low-range gearbox for low-speed operations. The high-low range lever selects which speed range to use. In addition to changing the speed, this also reverses the motor direction. So if you want forward and low range, switch the power switch to reverse. Up here is the pneumatic power drawbar. We will be going over the pneumatic power drawbar later in this video. The vise holds your stock in place. Remember to flip the handle so you don't accidentally bump into it. Next up are the table controls. These are the x-axis hand wheels, which moves the table in the x direction. This is the y-axis hand wheel, which moves the table in the y direction. The x and y hand wheels have a small dead zone, which is called backlash, where the table won't move when you rotate the hand wheels a tiny bit. To overcome this backlash, you'll have to slowly rotate the hand wheels more. The knee crank moves the table in the z direction. Try not to move the knee too much, since it can be expensive and hard to repair. Instead, use the quill to bring the tool to the table if possible. The DRO, or the digital readout, is used to show where the spindle is relative to a user-defined 0. This is similar to the DRO used on the lathe. This will be explained in more detail later. Here's how to turn the milling machine on. Here's how to turn it off. When the milling machine is on, keep your hands away from the spinning cutter. Before making any stock or tool adjustments, always turn the motor off and use the brake to fully stop the spindle. In case of any injury, report it to a mentor, even for a minor injury. If any of the equipment or tools break, report that to the mentors immediately as well, so that it can be fixed or replaced as quickly as possible. This is a collet. Collets hold tools of certain diameter in the machine spindle, similar to the lathe collet. We have many different sizes of collets, each with a different hole diameter. We use the 1/2 inch diameter collet most of the time because most of our tools have a 1/2 inch shank. The shank is the smooth part of the tool that is gripped inside the collet. Tools include end mills, edge finders, and drill chucks. To insert the collet and the tool into the mill, first inspect the end and alignment slots of the collet, as well as the nose or the angled part of the mill spindle, to make sure that they are free from any metal chips. Then slide the tool into the collet. Don't insert the cutting edge, which are also called flutes, into the collet. Now that we have our tool ready, let's insert it into the milling machine. This is the power drawbar. It's a tool that automatically tightens your collet and tool into the spindle. On the side of the milling machine, there are 2 buttons labeled in and out. When you want to insert something into the spindle, you use the in button. When you want to take something out, you press out. Now, let me show you how to use the power drawbar. Here are the steps for inserting a collet and a tool into the spindle. In this case, I'll be inserting a cutter known as the end mill into the collet. Number 1. Bring the quill all the way to the up position. Number 2. Lock the quill. This prevents the quill and the quill handle from moving around. Number 3. Insert the collet and end mill into the spindle together. Push the collet all the way into the spindle until you feel it contacting the top of the spindle. Number 4. Make sure your fingers are below the bottom of the collet. Do not have your fingers near or on the sides of the collet. Number 5. While keeping the collet pushed up against the top, press and hold the in button until you hear the pitch change. Once you hear the power drawbar's pitch drop, immediately let go of the in button and the collet plus end mill. Lastly, don't forget to unlock the quill. Also, never insert and tighten a collet without a tool inside the collet. Tightening a collet without a tool can deform and severely damage it. Here are the steps of removing the tool from the collet. Number 1. Bring the quill all the way to the up position. Number 2. Lock the quill. 3. Have your hand right below the tool. You can bring your hand close to the tool. Number 4. Press the out button to start loosening the spindle. If you want to take out both tool and collet, you can hold the out button until they both come out. Otherwise, if you want to just take the tool out, then hold the out button for a shorter amount of time. It's no big deal if you accidentally remove the collet. You can always put it back in. The last step is to unlock the quill. And that does it for the first installment of our GRT Mill training series. I hope this video has given you a better understanding of what a milling machine is. If you have any questions, feel free to ask them during class so that everybody can learn the answers. Stay safe everybody, and I hope to see you all working here soon.